I still remember the night we saw it. At first, it looked like just another blip, something to log, catalog, and move on from. But the more we stared, the less it behaved like anything we'd ever known. Objects in space follow rules. They obey gravity, drift with predictable arcs, shine or fade as expected. But this one broke the script. It was October 19, 2017, and I was working the night shift at the Haleakala Observatory in Hawaii. The Panoramic Survey Telescope and Rapid Response System, PAN-STARS for short, had been methodically scanning the sky for weeks, hunting for near-Earth asteroids. Routine work. The kind that keeps astronomers employed but rarely makes headlines. Robert Warwick, one of our postdoctoral researchers, was the first to spot it. He'd been reviewing images from 4 nights earlier when something caught his eye, a faint streak of light that didn't belong. "Hey, can you take a look at this?" he called over to me, his voice carrying that particular tone astronomers use when something doesn't make sense. I rolled my chair over to his workstation and peered at the monitor. There it was, a tiny point of light barely distinguishable from the background stars, moving across the field of view in a way that immediately grabbed my attention. "Fast mover," I muttered, already running mental calculations. "How fast?" Robert pulled up the preliminary orbital data, and both of us went quiet. The numbers were wrong. Not wrong in the sense of calculation errors, but wrong in the sense that they described something that shouldn't exist. The object was moving at 26 kilometers per second relative to the sun, but more importantly, its trajectory was hyperbolic. It wasn't bound to our solar system. It was just passing through, like a cosmic tourist on a brief visit before heading back out into the void between the stars. "That's impossible," I said, though even as the words left my mouth, I knew they weren't true. We'd predicted this moment for decades. Scientists had theorized that interstellar objects must occasionally wander into our solar system, refugees from distant star systems ejected by gravitational interactions or stellar explosions. "When was the last frame we caught it in?" I asked. Robert scrolled through the data. 3 days ago. It's already past its closest approach to the sun and heading outbound. We almost missed it entirely. That sent a chill down my spine. This visitor from another star had swept through our solar system, made its closest approach to our sun, and was already racing away toward the constellation Pegasus. If we'd been looking in a slightly different direction, if the weather had been cloudy, we would never have known it was there. How many others had we missed? The next few hours blurred together in a haze of calculations, confirmations, and growing excitement. We contacted other observatories, requesting follow-up observations. The data that came back confirmed what we'd already suspected, but hardly dared to believe. We were looking at the first confirmed interstellar object ever detected in our solar system. But as the observations accumulated, something else became clear. This wasn't just any interstellar object, it was deeply, profoundly strange. First, there was its shape. Most asteroids are roughly spherical, or at least potato-shaped. Comets might be a bit more elongated, but even they tend toward roundish blobs of ice and rock. Initial observations suggested our visitor was different, much more elongated than anything we'd ever seen. Some estimates put its length-to-width ratio at 10:1, making it look like a cosmic cigar tumbling end over end through space. "It's like someone took a normal asteroid and stretched it," said Dr. Sarah Chen, our team's orbital dynamics specialist, during an emergency meeting the next morning. "I've never seen anything like it." But the shape was just the beginning. As more data came in from observatories around the world, a pattern emerged that made no sense according to everything we knew about how objects behave in space. Oumuamua, we'd given it that Hawaiian name, meaning a messenger from afar arriving first, was accelerating. Not much. The effect was tiny, almost within the margin of error. But it was real, and it was consistent. As the object moved away from the sun, it was speeding up by a few centimeters per second per day. For any normal object, Solar gravity should have been slowing it down as it climbed out of the sun's gravitational well. Instead, Oumuamua was acting like something was pushing it. Comet outgassing, suggested Dr. Martinez, our resident expert on cometary physics. It's probably made of ice that's sublimating as it gets closer to the sun. The escaping gas creates a tiny rocket effect. It was a reasonable explanation. We'd seen it countless times with comets in our own solar system, but when we looked for the telltale signs of outgassing, a visible coma, a tail, spectroscopic evidence of water vapor or other gases, we found nothing. Oumuamua was accelerating like a comet but looked like an asteroid. It was behaving in a way that violated our basic understanding of how solar system objects worked. The team meetings grew longer and more intense as the weeks passed. Oumuamua was rapidly fading from view as it raced away from the sun, but every new observation seemed to deepen the mystery rather than solve it. "Look at this rotation data," Dr. Chen said during one particularly late-night session. She pulled up a graph showing how the object's brightness varied over time. It's tumbling with a period of about 7.3 hours, but the light curve is unlike anything we've seen. The brightness variations are enormous. It dims and brightens by a factor of 10 as it rotates. Consistent with that extreme elongation, I noted. When we're looking at it end-on, we see a small cross-section. When it rotates to show us its side, we see a much larger area reflecting sunlight. But even that explanation felt incomplete. The more we studied Oumuamua, the more it seemed to defy every category we tried to place it in. And then there was the color. Spectroscopic analysis revealed that Oumuamua was dark red, similar to objects in the outer reaches of our solar system that had been exposed to cosmic radiation for billions of years. But this color distribution wasn't uniform. It seemed to vary across the object's surface in ways that suggested a complex composition. "It's like looking at a piece of abstract art tumbling through space," I confided to my wife Elena over dinner one evening. "Every time we think we understand it, it shows us something new." She smiled in that patient way she'd developed over 20 years of marriage to an astronomer. "Maybe that's the point. Maybe some things aren't meant to be easily understood." Her words stayed with me as I drove back to the observatory that night. Oumuamua was now so faint that only the most powerful telescopes could still track it. In a few weeks, it would disappear entirely, lost in the cosmic background, never to be seen again. But the questions it raised would linger much longer. That night, as I stood outside the observatory looking up at the star-filled sky, I tried to imagine our strange visitor racing through the darkness toward destinations we could only guess at. Where had it come from? What star system had given birth to this elongated wanderer? And then, in the quiet of the Hawaiian night, another thought crept into my mind, a thought that would haunt me for months to come. What if Oumuamua's strange behavior wasn't the result of natural forces we didn't understand? What if it wasn't natural at all? The idea seemed absurd, the kind of speculation better suited to science fiction than serious astronomy. But as I thought about the object's bizarre characteristics, its extreme elongation, its unexplained acceleration, its uniform composition, I couldn't shake the feeling that we were missing something fundamental. The scientific community erupted within days of our announcement. Oumuamua had become the most controversial object in astronomy. Every major observatory on the planet was trying to squeeze out one more observation before it disappeared forever. Email chains stretched across continents. Conference calls ran deep into the night as researchers shared data, theories, and increasingly heated arguments. The media had already caught wind of the story. Headlines ranged from the scientifically cautious to the sensational. My phone rang constantly with reporters asking if I thought Oumuamua could be artificial. No comment, I'd tell them, but privately, the question was eating at me. The more data we collected, the stranger it became. Dr. Robert Varick had been running detailed analysis of its surface properties. What he found was deeply unsettling. "Look at this," he said, pulling up spectroscopic data during one of our late-night work sessions. "The surface composition is remarkably uniform. Most natural objects show variation, different minerals, impact craters, weathering patterns. But Oumuamua's surface looks almost manufactured." I leaned over his shoulder, studying the graphs. He was right. The spectral signature was unnaturally consistent, like looking at a piece of metal rather than a chunk of rock and ice that had been tumbling through space for millions of years. That night, I couldn't sleep. I kept thinking about Oumuamua's characteristics: extreme elongation unlike any natural object we'd seen, unexplained acceleration with no visible outgassing, uniform surface composition, and a trajectory that brought it remarkably close to the inner solar system, almost as if it had been aimed. Elena found me at 3 a.m., sitting at the kitchen table with my laptop, scrolling through observation data. "You look like you've seen a ghost," she said, settling into the chair across from me with a cup of tea. "Maybe I have," I admitted. "Elena, what if this isn't just a rock from another star system? What if it's something else?" She was quiet for a moment, studying my face. "You mean artificial?" It was the first time either of us had said the word out loud, and it felt like crossing a line I couldn't uncross. "The thought has occurred to me," I said carefully. "The shape, the acceleration, the surface properties, none of it fits what we'd expect from a natural object." "But you're a scientist," she pointed out. "You deal in evidence, not speculation." "That's just it," I said, pulling up the latest trajectory analysis. "The evidence is what's making me speculate. Look at this path." I showed her the computer simulation of Oumuamua's journey through our solar system. The trajectory was elegant, almost artistic, a hyperbolic arc that brought it close enough to the sun for detailed observation, but not so close that it would be destroyed. "It's like it wanted to be seen," I said. Elena studied the trajectory with her analytical mind. How many objects would follow a path like this naturally? Statistically, very few. Most interstellar objects would either miss the inner solar system entirely or plunge too close to the sun to survive. This trajectory is optimal. The next morning brought news that changed everything. Dr. Avi Loeb from Harvard had published a paper suggesting that Oumuamua's characteristics were consistent with artificial origin, possibly a light sail, a thin sheet of material designed to be pushed by stellar radiation. The astronomical community's reaction was explosive. "Loeb's lost his mind," muttered Dr. Chen during our morning team meeting. "You can't just publish wild speculation without extraordinary evidence." But I found myself defending the idea. What if the extraordinary evidence is staring us in the face? What if we're so invested in natural explanations that we're ignoring the obvious? The room went quiet. These were people I'd worked with for years, colleagues who trusted my judgment and scientific rigor. Dr. Martinez broke the silence. "David, you're talking about the possibility of alien technology. Do you understand what that would mean?" I did understand. It would mean that intelligent life existed elsewhere in the galaxy. It would mean that this intelligence had developed technology capable of interstellar travel. It would mean that they had visited our solar system, perhaps even studied us, and then continued on their journey. It would mean we were not alone. The debate raged for weeks. Teams of researchers proposed increasingly exotic natural explanations: hydrogen icebergs, fractal dust aggregates, exotic materials formed in interstellar space. But for every natural explanation, there were problems. Meanwhile, the artificial hypothesis explained everything: the shape, optimized for solar radiation pressure, the acceleration, light sail propulsion, the surface properties, manufactured rather than naturally formed, and the trajectory, deliberately designed for observation. "Occam's razor," I found myself saying during yet another heated conference call. The simplest explanation that accounts for all the observations is that Oumuamua isn't natural. As Oumuamua faded from view, disappearing into the constellation Pegasus beyond the reach of even our most powerful telescopes, the intensity of the debate only increased. This wasn't just academic anymore. This was about the possibility that we had witnessed humanity's first encounter with technology from another civilization, and we were letting it slip away. Late one night, as I stood outside the observatory looking up at the stars, I tried to imagine what the beings who had created Oumuamua might be like. Were they still alive, somewhere among those distant points of light? Had they sent out dozens, hundreds, thousands of these probes to explore the galaxy? And most unsettling of all, if Oumuamua really was artificial, then what had it learned about us during its brief passage through our cosmic neighborhood? Had it cataloged our radio transmissions, our satellite networks, our technological signatures? Had it measured our atmospheric composition, our level of scientific development? Had it concluded that Earth was inhabited by an intelligent species worthy of further study? Or had it found us wanting? If Oumuamua was a scout, a probe sent to assess the civilizations it encountered, then its departure might not be an ending. It might be a beginning. I made a decision that night. I was going to find proof of what Oumuamua really was. 6 months after Oumuamua disappeared from view, I made a discovery that changed everything. I was deep in the archives, combing through observation data with obsessive focus. The official scientific community had largely moved on, but I couldn't let it go. That's when I found the pattern. "Elena, you need to see this," I called from my home office. I pulled up a 3D visualization I'd been working on, Oumuamua's trajectory plotted against the positions of nearby star systems over the past several million years. "The trajectory isn't random," I said, rotating the display. "If you trace it backward, accounting for stellar motion and gravitational perturbations, Oumuamua didn't just wander into our solar system by accident. Its path intersects with a remarkable number of nearby star systems, including several we know have confirmed exoplanets." Elena leaned closer. "You're saying it's been on a grand tour?" "More than that. Look at the timing." I highlighted several points along the trajectory. If my calculations are correct, Oumuamua would have passed through the Proxima Centauri system about 300,000 years ago, the Wolf 359 system roughly 600,000 years ago, and before that, a dozen other systems with confirmed planets. "David," Elena said carefully, "you're talking about an intentional survey mission." I nodded. "An automated probe, programmed to visit potentially habitable star systems and study their planetary environments, and we just happened to be its most recent stop." Over the next 3 months, I assembled a small team of researchers willing to pursue the artificial hypothesis seriously. Dr. Marcus Webb, a SETI researcher from Berkeley, brought expertise in analyzing potential artificial signals. Dr. Lisa Rodriguez from MIT contributed knowledge of materials science and spacecraft engineering. The breakthrough came from Dr. Webb. He'd been analyzing radio telescope data collected during Oumuamua's passage. There are periodic variations in the background radiation that correlate with Oumuamua's position and rotation, Marcus explained. "The pattern is too regular, too structured. It's like looking at a carrier wave, a baseline signal designed to transmit information." The possibility that Oumuamua had been transmitting data during its passage was both thrilling and terrifying. Dr. Rodriguez had been analyzing Oumuamua's physical properties. "If we assume it's artificial," she said, "then its design is actually quite elegant. The elongated shape maximizes surface area for solar radiation pressure while minimizing mass. The rotation provides stability during long-term interstellar travel." "You're describing an optimized interstellar probe," I said. The implications were staggering. If we were right, then Oumuamua represented technology far beyond anything humans had achieved. But more unsettling was the realization that we might have been observed, studied, and cataloged by an intelligence we couldn't comprehend. The paper that changed everything was published after 6 months of brutal peer review. Evidence for artificial origin and intelligence gathering mission of Interstellar Object 1I/2017 U1, Oumuamua, appeared in the Astrophysical Journal. The response was immediate and polarized, but buried beneath the professional criticism were private messages revealing a different story. Government agencies that had never shown interest in my research were suddenly requesting meetings. "David, we need to talk." The call came from Dr. Rachel Morrison, director of NASA's Planetary Defense Coordination Office. 24 hours later, I was sitting in a windowless conference room in NASA headquarters, facing officials whose security clearances were clearly higher than mine. What I saw on their tablets made my blood run cold. Trajectory plots showing not just Oumuamua's path, but 17 other objects, all with similar hyperbolic trajectories, all detected by military space surveillance systems over the past 20 years. "We've been tracking them," Director Walsh explained. "Small objects usually dismissed as debris or natural phenomena. But your methodology for identifying artificial characteristics, when we applied it to our data, patterns emerged. Object after object showed the same characteristics: controlled rotation periods, unexplained acceleration, trajectories optimized for planetary observation. What emerged was a picture that was both fascinating and terrifying. Earth had been under systematic observation for at least 2 decades. We weren't just dealing with Oumuamua, we were dealing with a systematic intelligence-gathering operation. The months that followed were surreal. Publicly, I continued my regular work, but privately, I found myself part of a secretive group working to understand what we now called the Visitation Program. Dr. Webb was brought in when classified data revealed electromagnetic signatures consistent with data transmission from multiple unidentified objects. The evidence was mounting. Not only had we been observed, but the intelligence behind these visits had been actively communicating their findings. Someone, or something, has been transmitting regular reports from our solar system toward specific star systems, Marcus reported. Dr. Yuki Tanaka had been analyzing the orbital mechanics of all confirmed artificial objects when she noticed something crucial. "The visits are accelerating," she announced. "What started as occasional visits separated by years has become a steady stream of objects arriving every few months." "Something's changed," she continued. "The number of artificial objects entering our solar system has increased by an order of magnitude in the past 5 years." "We achieved something," I said finally. "Some technological milestone that triggered increased interest." "Space exploration," I realized. We started seriously exploring our own solar system. We went from being a planet-bound species to one that was actively exploring space. If our assessment was correct, then humanity's first steps toward becoming a spacefaring civilization had triggered a dramatic increase in extraterrestrial observation. We weren't just being cataloged anymore, we were being actively monitored as we approached some kind of critical threshold. The answer came 18 months later, on a night that would divide human history. I was at the observatory when Sarah's voice crackled through the radio with unprecedented urgency. "David, get over here right now, something big is happening." I rushed over to find her staring at a display showing the outer solar system. What I saw made my blood freeze. They were coming back. Not one object, but dozens of them. The display showed trajectories converging on our solar system from multiple directions, objects emerging from the interstellar medium like ships responding to a signal we couldn't hear. 67 confirmed, more appearing every hour, Sarah replied. "And David? They're not following the usual pattern. These aren't surveillance probes making brief flybys. They're slowing down, they're staying." The objects weren't random in their approach. They were arranging themselves in a perfect geometric formation around our solar system, a complex polyhedron positioned at strategic points that would give them complete observational coverage. The most unsettling discovery came when Marcus analyzed the communication patterns. Instead of brief, periodic transmissions, the new arrivals were engaged in constant, complex data exchange, a network of artificial intelligence sharing information at a staggering rate. "They're not just watching us anymore," Marcus reported. "They're actively discussing us. The data volume suggests they're conducting some kind of comprehensive analysis of our civilization." Dr. Elena Vasquez, a linguist brought in to analyze communication patterns, made a chilling discovery. The communication bursts are synchronized. Every 12 hours, all objects transmit simultaneously toward the direction of Proxima Centauri. "They're reporting to someone," I said. "Something. The signal characteristics suggest they're communicating with a much larger intelligence." 3 weeks after the convergence began, Dr. Chen realized that the object's formation wasn't just providing observational coverage, it was creating something else entirely. "They're building an antenna array," she announced. "The objects are arranged in a geometric pattern that creates a massive radio telescope spanning the entire outer solar system." Telescope pointed where? Alpha Centauri. Our visitors weren't just observing us, they were preparing to communicate with something in the Alpha Centauri system. The transmission began at exactly 1447 GMT, broadcast simultaneously toward Alpha Centauri and Earth. "They want us to hear this," Marcus announced. "Whatever message they're sending to Alpha Centauri, they're making sure we receive it too." Dr. Vasquez led the decoding effort. What they uncovered changed everything we thought we knew about our place in the universe. "The message is structured in 3 parts," Elena announced during a global briefing. "The first part is a comprehensive report about Earth and humanity, our biology, our technology, our social development. It's incredibly detailed, based on observations going back decades. The second part appears to be a comparison. Our development measured against standardized criteria. We're being evaluated according to parameters that include technological advancement, social cooperation, potential for interstellar expansion, and what can only be described as species maturity." "And the third part?" asked Director Walsh. Elena smiled, the first genuine smile I'd seen from anyone in weeks. "The third part is a recommendation, and the recommendation is positive. There's more. The message isn't just a report, it's a request. Our watchers are asking for permission to initiate direct contact. Our cosmic observers weren't preparing for invasion. They were asking for consent before taking the next step. Whatever intelligence was behind this operation, it respected the concept of choice. Over the next 48 hours, world leaders engaged in the most important diplomatic discussions in human history. The debates were intense, but in the end, the decision was unanimous. Humanity was ready to take the next step. The response was broadcast using every radio telescope on Earth. We accept your invitation to communicate. We are ready to learn. The answer came 3 days later. Ladies and gentlemen, announced Director Walsh during a press conference broadcast to every nation on Earth, we have achieved first contact. The message was elegant in its simplicity. Mathematical relationships that demonstrated intelligence, followed by basic physical constants, and then something that took our breath away. Images of Earth taken from multiple perspectives over the past century. But it was the final part that changed everything. Coordinates. Specific locations in space where direct communication could be established. And a time, 6 months from now. As the message continued, it revealed the true scope of what we were dealing with. Earth wasn't the only world under observation. The message included references to hundreds of other star systems, other species, other civilizations that had gone through the same evaluation process. We were part of something vast, a galactic community of intelligent life. The beings observing us weren't invaders. They were representatives of what could only be described as a galactic federation, a network of civilizations that had evolved beyond conflict into something cooperative, Hidden within the mathematical structures were references to specific achievements in human history: written language, agriculture, electricity, the atom, the moon landing, global communications networks. They've been monitoring our progress against specific developmental milestones, Elena explained. And according to their criteria, we've recently crossed the threshold that marks a species as ready for interstellar contact. What threshold? I asked. The development of a global civilization capable of systematic space exploration and the recognition of artificial intelligence. In other words, the moment we became capable of recognizing their surveillance probes for what they were. Oumuamua hadn't been just another surveillance mission. It had been a test. Our response to that first confirmed interstellar visitor had been monitored, analyzed, and evaluated. The fact that we had recognized its artificial nature and begun systematically searching for others like it had been the signal our watchers were looking for. We had passed the test. 6 months later, I stood on the observation deck of humanity's first interstellar communication facility, built at the coordinates specified in the alien message. The structure was a marvel of international cooperation. Scientists and engineers from dozens of countries working together to create humanity's first embassy to the cosmos. Earth hadn't been randomly discovered. We'd been identified as a potential member species centuries ago, and our development had been carefully monitored until we reached the technological and social maturity required for contact. Oumuamua and the other surveillance probes had been filing regular reports on our progress, waiting for the moment when we demonstrated readiness. "Are you nervous?" Elena asked, joining me at the observation window as we prepared for humanity's first formal diplomatic contact with extraterrestrial intelligence. I thought about the journey that had brought us here, from that first faint blip on a telescope screen to this moment when humanity would take its place among the stars. Oumuamua had seemed like an ending when it disappeared into interstellar space, but it had actually been a beginning. "No," I said finally. "I think we're ready." The communication began at exactly 1400 GMT, transmitted through a network of artificial intelligence that had been patiently waiting in our solar system for this moment. What followed was the most important conversation in human history, a formal welcome to the galactic community. As the first words from our cosmic neighbors were translated across the screens, I realized that everything we thought we knew about our place in the universe had been wrong. We weren't alone, struggling to make contact with distant civilizations. We never had been. We were the newest members of a community that had been waiting patiently for us to grow up enough to join them. And it had all started with a small, elongated object tumbling through our solar system, an object we'd nearly dismissed as just another piece of cosmic debris. Oumuamua hadn't been our first encounter with alien intelligence. It was our graduation test. And finally, after millions of years of evolution and thousands of years of civilization, humanity had passed.